Every year, Nike produces millions of sneakers that not only support elite athletes, but also accompany people in their daily lives. Today, it is the most valuable sportswear brand in the world, with a presence in more than 190 countries and an annual revenue exceeding $50 billion. But behind every model, there is much more than design. There are craftsmen who, with the help of technology, create sneakers that can define an era. But how is a pair of Nike sneakers actually made? To find out, we travel to one of their production facilities to see the process. Nike was born with a clear idea: to create quality athletic footwear capable of competing with the major European brands. It all began when Phil Knight, a young runner, partnered with his coach, Bill Bowerman. What started in 1964 with sales from the trunk of a car soon transformed into a brand that would change the way we think about sports and style. The name Nike, inspired by the Greek goddess of victory, marked a symbolic beginning. Along with it, in 1971, came the famous swoosh logo, designed by an art student for just $35. That simple and dynamic mark would go on to become one of the most recognizable icons in the world. One of Nike's first innovations was the waffle sole, created by experimenting with a kitchen waffle iron. That lightweight, high-traction structure not only improved athletic performance, but also demonstrated the brand's practical ingenuity from the very start. But the defining leap came with the Air Jordan, created in collaboration with Michael Jordan. More than just sneakers, they became a cultural phenomenon that connected sports with fashion and urban identity. Since then, Nike has not just made shoes, it has created legends. So what is the process of making a pair of sneakers inside Nike's facilities? The creation of a Nike sneaker begins in its innovation centers, such as the Nike Sport Research Lab in Beaverton, Oregon. Here, designers, biomechanical engineers, and sports scientists collaborate to develop footwear that optimizes performance. The process starts with conceptualization, where teams identify the needs of athletes in specific sports, such as running, basketball, or soccer. For example, a marathon runner requires lightweight shoes with long-lasting cushioning, while a basketball player needs lateral support for quick movements. Designers use three-dimensional modeling software to create digital prototypes of each sneaker. These models allow for adjustments to details such as sole curvature, cushioning density, and the placement of structural reinforcements. In the case of the Air Max, designers calculate the exact pressure of the air units to balance comfort and stability. For Flyknit shoes, they define the weave density to maximize breathability. This process can take months, with hundreds of digital iterations before producing a physical prototype. Nike also collaborates with elite athletes like Eliud Kipchoge, who helped develop the Vaporfly. These shoes have broken world marathon records thanks to their carbon plate and Zoom X foam. Interestingly, during the design of the Air Jordan, the Nike team had to adjust the thickness of the sole after initial complaints from Jordan himself, who felt the shoes were too stiff. This direct feedback from athletes is a practice that Nike maintains to ensure that each model meets real-world demands. Once the design is approved, material selection is the next critical step. Nike uses a wide range of materials, each chosen for its specific properties. The uppers of the shoes often include breathable mesh for ventilation, synthetic leather for durability, and Flyknit fabric for lightness. The soles combine high-resistance rubber for traction with EVA or React foam for cushioning. For example, React foam, introduced in 2017, is 11% softer and more responsive than traditional EVA foam, according to Nike's internal tests. These and other materials like synthetic leather undergo abrasion tests to ensure they withstand wear and tear. The rubbers used in the soles are tested in climate chambers to simulate extreme conditions, from tropical heat to heavy rain. Nike has also experimented with unconventional materials, such as algae and coffee waste, to create prototype sustainable soles. However, these materials are not yet used in mass production. Now let's move on to physical production, which begins with cutting the materials. In factories located primarily in countries such as Vietnam, Indonesia, and China, which together represent 80% of Nike's production, laser cutting machines and robotic arms cut materials with millimeter precision. These machines are programmed with digital patterns that optimize material use and reduce waste. For example, a 2 square meter sheet of synthetic leather can produce up to 50 shoe uppers depending on the model. This process is so efficient that a single production line can process up to 10,000 pieces per hour. The soles require a separate process. For soles with air technology, Nike uses thermal injection molding, where polymers such as thermoplastic polyurethane are heated to 180 degrees Celsius and injected into molds that form sealed air chambers. These chambers, which range from 5 to 20 millimeters thick depending on the model, are filled with nitrogen gas to provide cushioning. Each chamber undergoes pressure tests that simulate up to 100,000 impacts, equivalent to running a full marathon. Waffle soles and other variants are made with high-density rubbers molded in hydraulic presses that apply up to several tons of pressure to achieve the exact texture. During the production of the Air Max 1 in 1981, Nike faced problems with the first air chambers, which would rupture under pressure. This led to the development of a new formula that remains the foundation of today's air technology. Now we move on to the most critical phase, assembly, where individual pieces are transformed into a functional sneaker. On the production lines, the uppers are stitched or bonded to the soles using industrial-grade adhesives or heat sealing, a process that uses heat to fuse materials without glue. Industrial sewing machines, capable of performing 2,000 stitches per minute, embroider details such as the swoosh or decorative patterns. On high-end models, like the Air Jordan Retro, embroidery may include metallic or reflective threads, applied by skilled workers who inspect each stitch. Assembly also involves the placement of insoles, tongues, and laces. The insoles, often made of EVA foam or gel, are inserted by hand to ensure a perfect fit. In models like the Nike Free, designed to mimic the natural movement of the foot, the uppers are stitched with elastic threads that allow flexibility without compromising structure. It is all a seamless blend of craftsmanship and cutting-edge technology. Before leaving the factory, each pair of sneakers undergoes a thorough quality inspection. Visual inspectors examine each shoe, checking for uniform stitching, properly centered logos, and material defects. In addition, mechanical tests are conducted in specialized labs. For example, flexing machines simulate 50,000 steps to assess sole durability, while traction tests measure grip on surfaces like concrete, wood, or wet grass. The sneakers are also subjected to torsion tests to ensure they can withstand lateral movements, which are essential in sports like basketball. A key Nike standard is weight resistance. Each sneaker must withstand up to 1,000 newtons of force without deforming. Ventilation tests, conducted in chambers that measure airflow, ensure that models like the Nike Pegasus offer proper breathability. In 2024, Nike reported that less than 0.5% of its sneakers had defects. Once approved, the sneakers are packed in the iconic Nike boxes, made from recycled cardboard and designed to protect the product during transport. Each box includes internal dividers to prevent scuffing, and the pairs are wrapped in tissue paper to maintain their pristine appearance. The boxes are stacked on pallets and shipped to distribution centers in regions such as Asia, Europe, and North America. Nike's logistics network, which includes more than 50 global distribution centers, processes up to 1 million pairs per day during peak demand periods such as Black Friday. Sustainability is a core pillar of Nike's production. In addition to Flyknit, the brand has implemented programs such as Nike Grind, which recycles used sneakers to create new soles, court surfaces, and gym padding. In 2024, Nike recycled more than 10 million pairs of sneakers, transforming them into 30,000 tons of reusable material. The company also uses low-impact dyes and water-based adhesives to reduce its environmental footprint. Nike's innovation does not stop there. In 2023, it launched the Nike ISPA, modular sneakers that allow parts like the sole or upper to be replaced, extending the life of the shoe. The brand has also experimented with three-dimensional printing to create customized soles, a process that reduces production time from days to hours. Additionally, Nike has invested in augmented reality technologies such as the Nike Fit app, which scans a user's feet to recommend precise sizing, reducing returns by 20%. Without a doubt, Nike has positioned itself as the #1 sports brand on the market, pulling far ahead of its closest competitors. And that is how millions of Nike sneakers are made. What did you think of the process? Let me know in the comments. If you have not subscribed yet, now is the time to do it. Give this video a like if you enjoyed it, Here are other manufacturing processes you might find interesting. See you next time.